Good morning, maayong buntag, bonjour, ohayo, buenos dias. I am Bondroel Gaspina and this is Group 5 and we are going to introduce to you the four basic types of chemical reactions, namely synthesis or combination reaction, decomposition reaction, single displacement reaction, and lastly the double displacement reaction. Now cue the intro.
Hi, how are you? I hope you're doing well despite the pandemic. And without further ado, I'm Rosel Catalan and let me introduce to you the synthesis or combination reaction. Now, the question is, what is combination reaction? We can tell just by its name that combination reaction is a reaction where two or more elements or compound combine to form a single compound. Such reaction is represented by the general equation of the following form. A plus B yields AB. The reactants A and B combine to form a new single product, AB, which is always a compound. Now, let's have an example. We have here hydrogen gas and chlorine gas as the reactants. These two reactants will combine and produce hydrogen chloride. Take note that the coefficient number 2 is added to balance out the equation. Discussing on how to balance an equation right now might be a little distracting, so we'll just focus on the types of reaction. Let's take a look at another example. A solid carbon plus oxygen gas. These elements will combine and produce carbon dioxide. And that's it for combination reaction. It's super easy, right? And now, to conclude our lesson, let's do a little quiz for this topic. Are you ready? Which of the following reaction is a combination reaction? Letter A, letter B, letter C, letter D. If your answer is letter B, then you are correct. And that's it. I hope you have learned a lot about combination reaction. Adios!
Hello everyone, my name is Janine Grace Delapa. Please lend me your eyes and ears for our next topic, which will be decomposition reaction. So, let me tell you what a decomposition reaction is. A decomposition reaction is the opposite of a combination reaction. It occurs when a single compound breaks down into two or more simpler products. This can be represented by the general equation. AB yields A plus B. Decomposition reactions are endothermic reactions, which means the reaction requires the addition of energy via heat or light in order for the reaction to take place. This is because it takes energy to break bonds, while forming bonds produces energy. So, I will give a very small recap about endothermic reaction. In endothermic reactions, energy is transferred from the surrounding to the system. The prefix endo means inside. Endothermic reactions also require activation energy to start. So the last one is endothermic reaction tend to involve breaking of bonds. You can actually predict whether a reaction will be endothermic or exothermic. By looking to see if bonds are formed, it is exothermic. So if it is broken, it is endothermic. So now, let me provide an example for decomposition reaction. A carbonic acid is an ingredient in soft drinks. A decomposition reaction takes place when carbonic acid breaks down to produce water and carbon dioxide. This occurs when you open a can of soft drinks and some of the carbon dioxide fizzes out. And this is the equation for this reaction. carbonic acid decomposes into water and carbon dioxide. And that's it for decomposition reaction. Are you ready for our fun little quiz? Alright, so my question is, which of the following reaction is a decomposition reaction? A, B, C, or D? If your answer is letter C, then you are correct. You are doing a great job so far. Congratulations! So, I hope you had fun learning about decomposition reaction. Thank you for listening. Bye!
Hello, I'm back, and for our next type of reaction, we have single-displacement reaction. Single-replacement reaction, also called a single-displacement reaction, occurs when one element replaces an element in a compound, generating a new element and a new compound as products. The generalized equation for this type of reaction is A plus BC yields AC plus B. To give you an idea of how this reaction occurs, here we placed a copper wire in a silver nitrate solution. Copper is more active than silver, so it replaces the silver in the silver nitrate compound. Our products will then be copper nitrate and silver crystals. Now, I have mentioned that silver is replaced by copper since it is more active. We know this by looking at the activity series of metals. The least reactive elements are down here at the bottom, and the most reactive ones are found at the top. Copper here is just above silver, hence it displaces it to form new products. In the single displacement reaction, active elements displaces less active elements in the compound, otherwise no reaction will occur. For instance, copper and nickel sulfate. As we can see here, copper is less reactive than nickel, therefore no reaction will occur. And that ends our lesson for the single displacement reaction. Let us now test what you've learned through a quiz. For this quiz, you just have to answer yes or no to the following questions. Ready? Here we go. Is iron strong enough to displace zinc out of the solution? Yes or no? If your answer is no, then you are correct. Now for the next question, will a reaction occur from this equation? Yes or no? If your answer is yes, then you are once again correct. And that's it for single displacement reaction. Thank you for tuning in and have a great day.
Another type of chemical reaction that allows us to predict what products the reaction will be is the double displacement reaction. Double displacement or double replacement reaction occurs when parts of two ionic compounds are exchanged, making two new compounds. A characteristic of a double replacement equation is that there are two compounds as reactants and two different compounds as products. In a double replacement or double displacement reaction, the cations and anions of two compounds switch places. We have here AB plus CD yielded to AD and CB, where A and C are cations or the positive ions, and B and D are anions or the negative ions. In the equation, we have AB compound as our reactant. We are going to replace the ion B to ion D to form another new compound, which is the product AD. Same with the CD compound by replacing ion D to ion B, forming new compound, which is CB. There are two equivalent ways of considering a double replacement equation. Either the cations are swapped or the anions are swapped. You cannot swap both. You would end up with the same substances you started with. Here is an example of a double replacement reaction. What cations and anions are participating in this chemical reaction? We have BaCl2 or the barium chloride added with Na2SO4 or the sodium sulfate. Looking at the periodic table, we can determine the charges for the barium ion, the chloride ion, and the sodium ion. Ba2+, which is the barium, is in group 2A. Na+, which is the sodium, is in group 1A. Cl-, which is the chloride, is in group 7A. Our final anion is a polyatomic ion, so we can't use the periodic table if we don't have the charge on sulfate memorized. But we can use the charge on sodium to figure it out. We need 2Na plus to cancel out the charge on our SO4, so the charge on our sulfate has to be 2 negative. Altogether, we have Ba2 plus, Cl negative, Na plus, and SO4 2 negative participating in our reaction. We know that like charges repel each other, so our anions Ba2 plus and Na plus are not going to come together. Something goes for our cations Cl negative and SO4 2 negative. For a chemical reaction to have taken place, something has to have changes, so we can put the barium back with the chloride and the sodium back with the sulfate. This leaves pairing the barium ion with our sulfate and the sodium ion with our chloride as our only option. So, Ba2 plus added with SO4 2 negative will have a product BaSO4 or the barium sulfate, and Na plus added with the Cl negative will have a product NaCl or the sodium chloride. Putting this all together and balancing our chemical equation, we get BaCl2 plus Na2SO4 yielded to BaSO4 plus 2 NaCl. That was a little handful, isn't it? But I hope you have learned something about the double displacement reaction. And now it's time for our quiz. Predict the products of this reaction. Feel free to pause the video and scan your periodic table. If you answered KNO3 and AgBr, you are correct. I hope this video gave you more knowledge about the double displacement reaction. Thank you for your participation. Bye-bye!